So welcome back everybody to this second session about the introduction to the Python programming language. And in this session we will basically cover file input and output, so how you can read files, and especially as this is a training for data scientists, how you can input-output CSV files and how you can treat CSV files with Python. So in order for this session to work, you need to get at the file that you can download on this link. So either you can just type it in your browser or download it in different ways, whatever you like to your machine. Just make sure that the file is kind of in the same folder where you started this IPython notebook if you started it here. If you're doing this course in Google Colab, just upload the file into Google Colab, then it should work. And the same thing, when you do it in Kaggle, you kind of have to create a dataset. Please refer to the Kaggle documentation in order to do this. Basically, you just have to have the right path. Here we show it so that it's in the same path as the notebook. Here is basically the file. We will open it quickly in a text editor to see what a CSV file looks like. That's kind of the story. We will work with this file and see how we can basically read data from this file or write data to files. And we also will talk a bit about data cleaning in this session. Okay, so I have here again my IPython notebook environment. I also wanted to open basically this file in Emacs. I have downloaded it here in the download section, and we have here, if I open this with my text editor is called Emacs. Of course you can use something else like Notepad or whatever you have on your machine if you're in a Windows environment or whatever kind you are. Here in this Unix environment I have the Emacs text editor, so I will just open this file, and as we see, basically we have here, this is one line, so maybe I make this here a bit bigger so that you can read it better. And we see that in this line here, the first line basically gives us the description of each column, and each column, the values are basic, as it says, CSV stands for comma separated values, so you see that each column is separated by a comma here and here. And then we have just the columns filled out in the same direction as the labels are in the first column. Okay. Sometimes people say CSV file, but the CSV file is not comma separated, but has different separators. You can specify the separator in most import systems. This especially comes from different languages. In different languages than the English language, people use the comma instead of the point here, and then they need a different symbol in order to separate the values, of course. Here we use the traditional CSV file where we have just commas which separate the CSV file. Okay? As you see, we have here the data inside, and we will work with this data. This data comes from a cancer dataset. What do we have here quickly? Just a quick overview. We have radius, texture, perimeter, and we have this kind of 3 times if you look in here. So we have radius 1, texture 1, perimeter 1, and the age of the patient, so this is a patient table, and then we have a treatment date and a diagnosed date, and basically a column which is called cancer type, if this guy has cancer or not. And what we basically want to do is to build later on a machine learning model which predicts us from these 9 values and the age, and basically these values. So let's say from these 12 values, whether this person has cancer or not. Typical machine learning problem as we have learned it in the first session. In this session we will go a bit differently. In this session we will kind of show that we will just clean the data, so we will find out that this data is not clean. We will talk a bit about dates, how we can work with dates, how we can work with the cancer type, how we can work with all this together. Okay? Thank you. So let's go back to our Emacs IPython environment, and let's work a bit with this file. So how to open a file in Python? So there is kind of the open command. So we do F, and then we write here open. So F is just a variable which kind of behaves this file object, or which becomes this file object if you want to. And as the file is in the same folder as it as this iPad notebook, we can just open it directly by typing the file name. Otherwise, we would have to write out with slashes, with forward slashes in a Unix environment, with double backslashes in the Windows environment, the full path, and something like in Windows like C double point and blah blah blah, and the path to your file. Yeah. Here, as we're in the Unix environment, and as basically we would use forward slashes, but the file is in the same folder, so we use the train data, and we can autofills it here by typing the tabulator as it's in this folder here. And we have to specify basically how we want to open this file. And here we have kind of an R specifier or a W specifier for write mode or for R mode, and then we can rewrite, basically open the file. In this case, we just want to read it in as textual data. Yeah, if you want to read binary files, you have RB, different specifiers. Just look it up in the Python documentation later on. Here we will treat text files, and in general, you can read every file like a text file in most of the cases. Yeah. So let's open this file and see what we can do with it. Okay, so we have the file open. Then we can, for instance, read data as we have it in read mode from this file. And the file object basically then provides us with a read function that gives us this functionality. And here basically we have a value that we have to set, that we can set here. So I will just call this here content, yeah, and I write here 10, and what this does here is, if I write here 10, it reads the first 10 bytes from the file, from the beginning of the file as we have just opened it, yeah. If I do subsequent calls on this read object, then the content changes, because there's like these files, they have like a pointer inside, and this pointer is always set to the last byte that has been read with this read function. So if I do this, just to explain this a bit, let's read the first 10 bytes. So each byte normally corresponds to one character, at least in Latin languages. If you're using, for instance, in Chinese, they have multi-byte characters. This is not true, but in our case, each byte corresponds to one character. So what I've done right now is I read 10 bytes, 10 characters from the file. Yeah. So let's see what this looks like if I type content. And as you remember, in the first thing that was there was the first column, and the first 10 characters, the first 10 bytes correspond, of course, to the string. This is the content that we have read. If I do this a second time, and I write fread 10, what then happens is I write 10 subsequent bytes, and if I go to content right now, we see basically from the end here, I read the next 10 bytes. Yeah. So in order to set basically this file pointer to the right position, if for instance I want to rewind this file, so go back to the beginning of it, or let's say jump to a random position inside the file, I have the seek function. Yeah. So how does this work? fseek. And then if I say 0, so basically this is the offset in the file, so at which position, at which byte position I want to be. Also note, maybe confusing for beginners, a new line, for instance, is one additional byte. Yeah? So if you type the enter key when you edit the file, this is just 1 byte more, so it's basically just a string of bytes, each text file. And with the seek function, of course, you can go to the right position. Yeah. So let's type 0 in here, and then we're back at the beginning of the file. And if I then would basically read from this file, I would again read from the beginning. And if I run right now a read 10, then I would have radius underscore t, as we have done here. Okay. So fine, so good. Let's try some file I/O. So what I can do is basically, this was input. There is also output. So we have, let's name a file. Let's open a file and write an output, some output here. And let's say, okay, this is a text file, and open it in write mode. Okay, so this is the output file. What I can do here is then I can write to the file. So this file object then has a write function, and we can here basically write some text to it, in this case test. You have, like in C, you can look it up in the documentation, of course, special characters. For instance, the \n would be a new line character in order to break the line. There's also /t for a tabulator. Many different things that you can add here. If you want to \, of course, you have to write a /. Things like this. So right now, you can write these characters to the output file just with this write function, as long as this is kind of a string that you put in here. Okay. So if I do this, I wrote to the file. I get back that I have written 4 bytes to the file. This is kind of the output. If I can, to read the file and open it right now, always, we already forgot this for the first one, so we will close. Basically, always close your files when you use them, especially when you use them in loops and you write thousands of files. Very quickly it can become a problem, because let's say it like this, a Python program can only open 1024 files. For instance, imagine you, as a data scientist, you write some Python program which generates, I don't know, random images or something like this, and you create more than 1024 images and you forget to close the file in the loop. Then you run out of file pointers, as they are called, so these file objects, if you want to, and you can't, your program fails. So let's close the input file, and let's also close this output file that we have here. Once it's closed, it also flushes all the content. So if you do this write test, it might be that the file on the disk is not written. If you use this close, then it makes sure basically that the file is in this state on the disk. Yeah. This is kind of also the story, because if you open the file in the editor while you have written write, maybe it has not yet basically all the contents on there. Okay. So going back to our environment here, I will just quickly open this file in Emacs. So I already have this train data open here. So let's open the test file that we have here created. Just let's watch if we have all these files. So we have this output text file that we have here, and as you can see, we have here test written into it. It didn't make a new line character, so it's just one line. It stops here because we didn't put a new line at the end, which is different than if you call the print function. Okay, this is kind of the most basic file I/O, how it works, how you can read files into Python, and then you can imagine, for instance, you can read in this way numbers from a text file and transform them into floats, as I've just shown you using the typecasting that we have seen in the previous session. Okay, so fine, so good. This is the basic file I/O. Right now, what we want in the next part is we want to have basically to work with CSV files. Yeah? So built into Python, there is a CSV reader. So let's call this PSV reader, the CSV reader. So in kind of with every Python installation, normally the CSV part comes later. In this session we will see the Pandas, how you do this with the Pandas library. The Pandas library sadly is not installed in all installations, and if you don't have administrative rights you might not be able to install it. So let's just see how you can work it with CSV files if you don't have Pandas installed on your machine, which probably, in most probably cases, you have anyways. But let's go to the most basic back. So we have basically, we have to open our CSV file again. In read mode, so where was our file? I'm sorry, I forgot the name, so it's called train data CSV. So we open train data CSV, which is a path, and in read mode, in order to read this CSV file using this CSV functionality that comes with every Python installation. Okay? Okay, so we have our file, and then we can open something which is called the reader, and so we can create a reader object from the CSV library, and we call this reader function that is here, and it requires a file, and as I said, the delimiter, as it's not always the same, let's just specify it. In this case it was the standard comma, and then when we do this, we have the CSV reader open with the file, and in order to read the CSV file right now, of course, you have to be at the 0 position, which we are as we just opened the file. In other cases, you use this fseek function and go to the 0 position. Okay, so how can we read basically the data? This reader object is kind of a iterator which goes row by row over the CSV file and generates us for each row a list or with the objects that are inside this row. Okay, so how does this look like? We have here, let's do it very easy. We create an empty list, and we will create a two-dimensional list out of the CSV file so that you can grasp the functionality of how this works. Okay, so I will start with I equals 0, so I will have this kind of index in order to count how many rows I have in my file, and here I will go for row in reader. So this reader, as I said, is kind of this iterator file, it behaves a bit like a list, like a range, as you see. So for each row basically that is in our file, we will read like this, and then we can say, for instance, if I equals 0, as you remember, we can say then the description that we want to have should be the row. So this is kind of the description, the first line as we said it, and then otherwise we want the data be appended. So create a list in a list. This row, as I said, is a list per row to our data list, and then we get this two-dimensional object, of course, out. Yeah? And in order for this to work, afterwards we have to do I equals I plus 1 so that we can count how many rows we have, and we import our data. Okay? Okay, so let's do this. And this is basically done. This is very fast as the file is rather slow. And if then I do basically data 0, I get the first line of the file, and if I do description, then I get basically out the first line of this file, and you see that these are lists, and here I can basically iterate row over row into this data story and get basically the values out from each row. Okay, easy as that. So right now you see how basically you can read a CSV file, how you can create basically a list of lists with this data and get your data inside, and then you can, of course, as this is a list in a list and a two-dimensional object, you can do something like this and get of course, the first item, which is radio 0, from the second, third row, basically, of your data. This is how it works. Very, very simple and very easy. Okay? So right now I've shown you the CSV reader. Something else that we want to do is basically we want to do the same thing with the Pandas environment. So let's go over to the Pandas environment, which kind of simplifies this whole CSV stories. And in order to do this, we use import the Pandas library PD. So you already know from the previous session how the import command works. And this Pandas environment allows you to work with what they call the data frame, and in order to work basically with tabular data like this in a bit of a database fashion-like environment, and also to perform statistics and all kinds of things with the data, we will quickly introduce you into this and how to clean basically the CSV file. So we will find out using this Pandas environment that there are several problems with the CSV file, that not all the data, not the whole table, if you want to, is is filled out, and that there are several values missing, that there are wrong values, that there might be outliers and things like this. And we have to cover all of this with this kind of Pandas environment in order to do this data cleaning that we want to do. Okay? So let's do this. So we have the data frame here, and we read basically a new data frame. So let's read this data from the CSV file without using this CSV functionality that we have seen before. This time we will use we will use this data frame functionality, which is of course way more convenient than what we have done before. Okay? Which of course requires you to have Pandas installed on your machine, which might not always be the case. Okay, so we have the data frame here. We can get the first thing that you want to do when you read a file like this is that you want to get some info of the file. And what do we have here? Basically it says, okay, it has read all these columns. These columns have this kind of type, so this is a floating point number which requires 64 bits. We see that, for instance, for texture 2, for this column, it didn't know what to do because there are probably things inside that we have to fix this. This is probably also a float 64 as we can imagine, but right now it's an object because it couldn't really determine what kind of data it should use for this. We also see that the treatment and diagnose state is an object, and of course we want to do something with that. And we want to check how we can clean all this and how everything works. Okay? Okay. So to get a quick overview, we can just type df, and in this new IPython, let's say Jupyter Notebook environment, we automatically get basically a very nice view in the browser of our data frame where we see this list, and already we find some little problems. We see, for instance, that here perimeter 1 there, it's not a number, so he didn't know what to read for this. Here also this value has not a number, and we will take care about all these values and see what we can do, how we can treat them. Okay? Something else that one can do is one can kind of, if you want to have the rows as columns and the columns as rows, one can kind of transpose the data frame. So this is very easy to do, just to show you some functionality of this Pandas environment. And right now we see that basically our rows became rows here, and this became columns, and it's then a different representation of this whole thing. What you can do, for instance, what is very handy is you can sort this whole thing. So basically I can say then by which column, so in this case let's say sort it by age, and then we get the whole data frame sorted by the age column here in the out as a new object. Yeah? Okay. Something else then you can do is you can kind of permutate the rows. So how do you do this? By changing the index. So you can do the F3 index, and this might be handy sometimes as data scientists. You just don't want the data in the way you read it in, you want to have it kind of shuffled. And here we will do a random shuffle if you want to. So a random shuffle you can create it with the NumPy library that you have to import, of course, before you do this. So we do import NumPy as NP as we did it previously, and we can do a random permutation and on the index. And basically if you change this TF index, you have 398 rows, then you can basically change this index around, and then you have the rows in different order than before, and then we have our file randomly shuffled if we execute this cell here. Okay? We did this, and we see basically that it's randomly shuffled as I just said before. Nice to know. As we said, when we go back to the info, so let's just call again this info functionality that we have. And we have a problem here with the texture 2 column, as we found out. Let us convert this texture 2 column to a floating point object in the hope that it works. So how do we do this? So how do you select the column just like this? So let's just check this out. If I do something like this, then I get, of course, it works a bit like a dictionary. Then I get the column which corresponds to this object, and we want to change this column. So how do we change this column? So we take this column, texture 2, and we change it using this Pandas object to numeric, and we say here basically we have the data frame texture 2, okay, and we also have an error handling. So in this case we just say queers, and we do this, and what will happen right now, let's check it out. If I run our data frame, basically it worked somehow, and then we can see basically if we have df info, we see that our texture 2 has changed from object to float64, which is actually what we want. Yeah? Okay. So far so good. We have our numbers. Something else that you can do, of course, is you can plot the data. So we'll show quickly how you can plot data, how you can use plot functions in NumPy. So we have, for instance, this, or in this IPython environment. So we have a library which is called matplotlib. Again, this is also not installed in all systems, but hopefully in yours. Otherwise, install it with pip install or whatever your environment provides you as PLT, and we can use this PLT scatter function in order to kind of get this. So what can I do? We have seen this range object, and we take the length. So a length of a list or of an object, you can always use it with this len tool. We haven't shown this, I guess, in the previous section, but basically if I would have applied len on a list, I would have seen how many objects I have in the list. Here I applied a len on a column, so that I just get basically for the x variable the range of this column, and for the y basically the point, so that I can perform a scatter plot in a very easy fashion. So what does this look like? df, and let's say we want to plot this texture 2 column here, which right now should be numeric, and right now we have the range as the x-axis, and the y-axis, of course, we want to have the values. You could do this with a list. Here with the data frame we just call the columns, and you can plot this. You basically have here let's say a list or a range object in this case, which goes from 0 to the length of this texture 2 object, so which gives each a y point, a x point if you want to, and then on the other axis we kind of get the value of this texture 2 point. And if I do this, then I get out in this IPython notebook basically the plot, and I see here very well described how these values are distributed, which gives you a first insight. You can do this with all the columns, and which gives you kind of a first insight on your data. Okay, something else that we have here in this data frame, we said, okay, we have here a treatment date and the diagnose date, and what we basically want is we want to have kind of the difference from the treatment date to the diagnose date. Yeah? So we are not really interested in the hard values of the treatment date and the diagnose date, but we're probably interested, well, how long did it take from diagnose to treatment, and does the person still have cancer, something like this, and use this value kind of later on in our training when we train the model. Okay? Okay, so far so good. Let's do this. How can we use this? So this is also important if you want, as a data scientist, you work with time series, you probably want to work with time and date objects. So we have a library for this, which is called the datetime library, that I will import here. and we use this datetime library in order to convert our time objects to timestamps. I will quickly introduce you what the timestamp does, but just to get you how to create kind of a time object to work with time in Python. So let us create the time object. And how do you do this with this datetime functionality? So there's a function which is a subfunction of this datetime module, and it's called strptime. And here what I can do is principally I can provide a string like the one that we have. So for instance 2006 and the 1st of January, and I can say something like this, like %big Y, %m, and %d. And basically what this does is it takes here basically it describes the string, and from the string how to use these values in order to create the time from it. So here I need the big Y because I have 4 entries for the year. If I would have 2, I can just probably use a small y. Please refer to the functionality of this strptime. You can look it up on the internet how this functions in details. For here, this is fairly enough, because when I look at how this works here, I have month and day. This is actually how I want to read our times and how to create our time objects. Okay, so if I do this, I create a time object in Python, and then I can work with this time object like this. And I have my time object, and we see, okay, this is the year 2006, and this would be hours and minutes probably, in order to see or at what time we have this. What you can do with this time object is you can create a timestamp like this. So we can call a function on this time object and have this timestamp functionality. And with this timestamp functionality we get basically, I guess this is milliseconds or seconds, I'm not sure, right now, from the year from the first of 1970. And as this is kind of absolute, we can differentiate this. Yeah, so we can basically say, okay, we have our treatment date and we have our diagnose date, and as this is basically an offset in seconds or milliseconds from the 1st of 1970, 1st of January 1970, we can just calculate the difference and have kind of the difference between these two dates that we can use in our machine learning model. Okay? Fine so far. The date difference, how do we calculate this? So I will call this here difference in date. And the date difference, let's create a list first to work with this. And we do for e in range as we have learned it. We take the length of the data frame. As I said, this length, or how shall I say, this length operator is very, very handy. And what we will do is basically we will create our datetime object here, and we will do it just as we did it before. So we do datetime strptime. And then how can I access this? As I said, this is very easy. It works a bit like a dictionary, and as if you would have in this dictionary a list for each column. Yeah. So let's use this. So we have here treatment date. Okay. And then we say, okay, I want the I object, because here I count from 0 to the length of these objects above. We want to convert basically the contents, as all these contents are strings like this. We want to convert this content to basically to this time object in the way we did it here. So I will just copy paste this here over down here, so that we can do this. Okay, and then I can directly call the timestamp function. So as you see, if you create an object like this, even if you call the function, you can basically in Python directly use the dot in order to call from this resulting object a function on this or a method from this resulting object. Yeah? So we create basically this datetime object, and we call basically the timestamp method of this datem object directly here in order to store the timestamp in A, okay? And then we do the same thing for B. And here we don't want it, so I will copy paste this, but we don't want it of course for treatment date, we want it for diagnose date, as we've seen it before. And then we can calculate the date distance, how long did it take between treatment and diagnose for this patient. Okay, so how do I store this? So we have our diff date, as I said, list that we have created here, and we will just append this to the list as absolute values from A minus B, because these are just basically then integers or floating point numbers that we can subtract from each other. That's as easy as that, and if I do this and I run this, then I get my list, hopefully. I made here a spelling mistake that we will fix quickly. Okay, diagnose date, a second spelling mistake, diagnose date. And right now it should have worked, and if then I go to the length of my diff date list, then I see that this list has 398 entries, just as our data frame had. When we looked at the data frame, we see that each of these columns, not all of these columns, because there are some problems with them, but most of the columns have 398 entries. There's 398 entries in this diff date story here. And if, for instance, I want to get the second one, well then I do diff date 1, no? And we see that we get this difference between diagnose and treatment that we can use then later in our machine learning training in order to use to see how long did it take between diagnose and treatment. Okay. Well, that's nice. What we basically then want, we want of course to append this to our data frame. And how do we do this? So we can just basically create a new column in the data frame by just opening it like this and give it a name. So we will call this diff diagnose treatment, like this. And if we do this, we basically create a new column, and we can just add a list. So if you have a list and you want to basically add a column to your data frame, it's as easy as that, and we have a new column in our data frame with this difference. So if we right now show the data frame, we see that here we have diff diagnose treatment date with these values, basically, which are the difference between when diagnose and treatment happened. Okay, fine, so good. What we want is, of course, right now we can get rid of these entries, so we can get rid of treatment date and diagnose date. So how do we do this? You can use the pop functionality, just as we have seen it before. So we can just pop, of course, diagnose date out, because we don't need it anymore in this data frame. And we get it back, so we could store it back, for instance, here as diagnose whatever, and then would get another data frame with just this column, but here this column is kind of lost right now from the data frame. So if we just check it out, if I type data frame, we see that the column basically is gone, and we want also to get rid of the treatment date column. So I will do this a bit quicker here, so I just copy paste treatment date here and pop it out just as we did it before by changing this here, and run this again. And then when we see here basically our data frame, as I said, this is kind of a state-like object, so you can always go back and use the functions that you have already used. You just have to make sure that you know what you're doing, and we see that basically both of them are lost, and we have retained our difference in diagnose and treatment date. Okay, so far so good. Right now you know a bit how you can work with the state objects. What we want to do basically right now is we want to create kind of a clean data frame. So we want to clean this, and we have this not a number of values in here. And what we can do is basically we can just drop them out of our data frame. So how can we do this? Let's use this, we call this df clean, and let's clean this, and there's a very easy functionality which is kind of df, so the data frame, and we can say drop na, and we can say if we do this, basically all of them are gone, and we can basically look at this, and then if we have df clean, we see that we have only 199 rows left, because all entries where this kind of data is gone is lost. Yeah? This is a very easy way to clean this, and right now we have numbers everywhere, we have numbers at the right point, and we have the cancer type here. And of course the age, the difference in diagnosis and treatment date, and we have our nice data frame. Of course, as you see, we lose a lot of data if we do this, so there would be different ways to do this. I've shown you how you can access kind of all of these values. So you could access these values and replace them by the mean and things like this. Here, for simplicity of this tutorial, we will just use drop na in order to clean our data frame, and for this little introduction into data cleaning. Okay? Okay, so fine, so good. We have our columns. What we can do right now is we have this, and we have basically a data frame only with values. We can use, for instance, this df clean, and there is kind of a correlation functionality in this Pandas story here, and we can calculate the correlations between all the columns, which is the Pearson correlation, and we see of course that if within this matrix how each column is correlated to each column, and what interests us of course is basically the cancer type column, and here we can basically then read from which line is the higher the values here, the higher the absolute values are here, and the more important probably this value. So here if I go this line here forward, so for instance I see here parameter 0, that parameter 0 will probably have a high impact if this person will have cancer or not. The same thing for the subsequent values that we have here, which basically gives me a simple overview already of which kind of values will be important and which will not be so important. So we see here that this here is the radius, as far as I remember, so radius 0, and that of course also radius 1 doesn't have that much of an impact on the cancer type. Yeah? We see also that the difference in diagnosis and treatment, we calculated it, but the impact will probably be small on the cancer type as we see it here. Yeah? So this already gives you a first insight on, as a data scientist, on how your data impacts basically your outcome with this Pandas a quick statistically test. Yeah. Okay, the next story, what we can do is, for instance, you can filter this data. So for instance, what you can do is df, and then you can say, okay, I want to have a column like radius 1, and I can filter, for instance, with these Boolean operators where it's bigger than 15, and then when this is true, basically it returns it to you. And if I do this, then I get 113 columns, only those where the radius 1 is bigger than 15, for instance. Yeah? And you can use this here in this story here to use these Boolean operators basically to filter rows. For instance, you can use the equal sign if you know a value especially, and then you get only lines where this is equal, of course. Yeah, just as we used the Boolean operators when we used the if statement before, and as we have seen them in the last session. Okay, so far so good. Something else that would be interesting for this, how to work with these data frames, is the df location. For instance, let's see it here. For instance, let's say I want to get a subframe, I can do something like this. Let's just show how this works so that you kind of get an idea on how I can use this. So I need a list here of columns. Okay, and if I type this like this, what happened here, as you can see, here I can use this just as we did it with the list, so it goes here from 3 to 8, yeah, okay, 8 inclusive here, just to check it out, we start here at 0 as far as I get it, and we see here basically that we have the columns here, radius and perimeter, and we get this kind of subdata frame out of it, so from the 3rd row to the 8th row, actually from the 4th row to the 8th row to the let's say for the 4th to the 9th row in this case here, with this radius and perimeter story, we get this subdata frame out of here that we can cut out with this location sub functionality of this data frame. Okay, very easy, no? Right now, as we have our clean data set, we will stop here for this data set here, and what we want to do before this, of course, is we want to save the data as a clean data because we will need it in another session. But let's go back to our clean data frame, and we can then say to CSV. So if you have operated on a data frame like this, you can use this to CSV functionality in order to store it to a CSV file. And we use train data clean.csv. Okay. Here I open the CSV file. You can use the same functionality basically with Excel files. So you can read XLS, something like this. To read from Excel files, you can look it up in the Pandas documentation. You can just type on the internet Pandas how to read Excel files. You can read probably also from SQL servers and things like this. Look up the functionality on the internet in order to get your data basically into Pandas data frames. If you have tabular data, this is a very handy functionality to use. Okay, let's go back to our story here, and let's save this file. And we basically have right now our clean data stored back to a CSV file. We can use Emacs here to open the CSV file. So if I do this, all of this runs in the downloads folder here on my local machine. So we see that we have created this file here, and I can open this here so that you can see what this looks like. And we see that the clean CSV file basically looks like this. We get this index column, which is not very handy, but it stays here as we permutated this. It's a bit permutated, but we could write like index here in front of it in order to keep this index column. Otherwise, we get, when we re-import it here, like unnamed 0 or something like this. We will treat this probably in the next session when we will build models from this clean data file, where we actually will predict what kind of cancer type each data has. This is kind of just the data I/O and data cleaning session. This then comes for the next session. Okay, one last thing that I want to show you basically is how you can create a data frame from a dictionary. So this is kind of the most easiest way to create a data frame. So if you want to create a data frame basically from Python data that comes from wherever that you have read from a text file that is not in CSV mode or from something else. So something that you can do is like, if this is my data, you can create something like a dictionary. And if this dictionary, for instance, looks like this, so let's do it like this here. And here we have 2, 3, 1. Let's say it like this. So this is kind of your A column. So for each column, the easiest way is you write columns and create lists with your data backwards here. And then we can do like the B column. And we can say here, okay, here we have another list, like, I don't know, A, let's do it like this, C, and then we do it to make it a bit permutated, D here, or the names of these objects, for instance, and this is my dictionary, and in this way you can then use this dictionary if it has kind of a shape like this, with the names basically here of the columns, and here lists of the column contents. Of course you have to make sure that this makes sense, so that these lists have all hopefully the same number of entries. Then you can do something like this and can say my data frame, and do PD encode data frame functionality on your dictionary that you have created, and then you get the data frame out. And this way you can kind of programmatically create these data frames. Okay? I hope this all is very informative. This was kind of the how to treat data, input, output, how to work with files session. And the next session will be on machine learning. Thank you so much. Thanks.